5.3a, similar figures. This is just another lesson that is using proportions to solve. This entire week we're using applications of solving proportions. So, figures that have the same shape but not necessarily the same size are similar figures. The symbol that is written there means is similar to. I'm going to show you. That symbol right there means is similar to. You can use proportions to find the missing length of a side in a pair of similar figures. Okay, so first of all, this that I'm highlighting, you would say triangle ABC is similar to triangle DEF. Now, there's some things that you got to know about that. First of all, there are things called corresponding angles. That means the angles that are in the exact same spot in the triangles. The angles that are in the exact same spot. So it's telling us that A and D, it's telling us that A is congruent to D. So A and D are in the same spot. It's saying B and E are congruent because B and E are in the same spot. And then finally it's saying C and F are congruent. Those are both the right angles. Okay, those are called corresponding. In similar figures, those angles have to be exactly the same. That's how it keeps the shape the same. But the sides, they're not going to be the same. The sides are not going to be the same, but however, they are going to be proportional. So, AB and DE. So it's saying this side compared to this side is going to be in the same ratio as any other set that corresponds. Any other set that corresponds. So if you look at A, B, and DE, that's in the ratio of 5 to 10. Well, BC and EF are 4 to 8. And then the last two, AC and FD, 3 to 6. What are those all reduced to? 1/2. Those all reduced to 1/2. They are all in the same ratio. They are proportional. Now, here's what's going to happen. They're going to give you two shapes. They're going to give you two shapes. And they're going to give you some measurements on the two shapes. So let's look at these two rectangles. Let's look at these two rectangles. It says right here that MNOP is similar to RSTU. It's got a 7 that matches a 28. Then there's a 5. What does the 5 match on the bigger rectangle? Well, which side? I'm sorry.
On the right side.
This side, the ST. So this one would be my X, or my N, I guess it's calling it. So you would write a proportion small to big, and you would go 7 to 28 equals 5 over X. You pair up the sides from the smaller figure to the bigger figure, and then you would do what we've done with every proportion. You do your cross, cross, and solve. So let's try some all on our own that aren't done, that isn't done already. Let's look at number 1. Let's look at number 1. I'm going to set up this proportion, and I'm going to go small to big. So obviously ABC is small and DEF is big. Which two sides match up from the small to big? Which two sides are given that match up? The 3 and the 9. Do you see that? 3 on the left, 9 on the left. So if I put small over big, which one's going to go on top? 3. 3 over 9. Okay, which other two sides do they have matched up? 5 and x. So which one's going to go on top? 5 and x on the bottom. Do you see how we've got yet another proportion with one thing missing? So I'm going to solve it like we've done all the rest of them. Cross, cross. So 3 times x equals 9 times 5. 3x equals 45. Divide by 3, x is 15. How would you think I would label that 15? Meters. You're going to label it whatever the other ones are. What questions do you have? What questions do you have? All right, let's look at number 3. Let's look at number 3. Just for the sake of kind of mixing up, showing you could do it either way you go, let's go big over small. We're going to write a proportion like always. Fraction bar equals sign fraction bar. Big over small. What two corresponding sides are listed that match up from the big to the small? Caden? What? 10 and 5. 10 matches 5. 10 over 5. What other two sides match up now? X and 9. Which one's going to go where? X on top because it's from the big. X matches up with the 9. X over 9. Now, is there anybody in here that cannot see how we wrote that? We went from the big rectangle to the small, and you match the corresponding sides for each ratio. After you fill in all the spots, you're going to cross, cross. So 10 times 9 is going to equal 5 times x. And 90 equals 5x. Yes? Not necessarily. They could have, it just depends on which one they give you the missing one on. But that's a good question. It could be on either one. It could be on either one. What's the last step towards solving that? Divide by 5. So that x equals 18. How would I label this one?
18.
Yards. Okay, are there any questions? All right, on your papers, I'm gonna pause this for a minute. I want to look at number 2. On your papers, I want you to write the proportion for number 2. I'm going to hit pause on the video. So I've given you a minute or two to write your proportion. So are we going to go small to big or big to small?
Small to big.
Small to big. So out in front, I would write for myself small over big so I know how to fill in the numbers. And I put fraction bar equals sign fraction bar. Okay, which set of sides do they give both values? Which sides are corresponding that match from those one triangle to the next? Liam. 4 over 12. 4 from the small matches 12 from the big because they're both on the bottom like that. Then the other set that are corresponding that they've listed, what are they, Nico? 2 over x. 2 from the small, x from the big. How many of you had that proportion written?
Even if it's flip-flops?
Huh? If you had 12 over 4 and x over 2 is good, or if you had 2 over x equals 4 over 12, that's good. Yep. Okay, now you cross, cross. So 4 times x equals 12 times 2. 4x equals 24, and divide by 4. How much is this? 6 what? Feet. 6 feet. All right, good job.